Good day, grade 12 learners, and welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, so for today's knowledge area, we'll be dealing with waves, sound, and light, which has a total of 24 marks. And today's topic will be focusing on electromagnetic radiation, which is your question 7, and it consists of a plus minus 8 marks there. Now the mark allocation for paper 1 is that you have your section A, which consists of 10 multiple choice questions and has a total of 20 marks. Section A also consists of either 8 matching items or 8 one-word items, which has a total of 8 marks. Then you have your section B, which consists of structured or long questions and has a total of 122 marks. Now the total for paper 1 is 150 marks with a duration of 3 hours. Now learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. So now the topics to be covered in paper 1, we have under content, we have biomechanics, which has a total of 93 marks and a percentage weighting of 62. And then we have electricity and magnetism, which has a total of 33 marks and a percentage weighting of 22. Then we have your wave, sound, and light, which has a total of 24 marks and a percentage weighting of 16. Then in terms of the examination guideline, this is what you need to know. So you need to be able to define what? You need to be able to define an electromagnetic wave. So it says define electromagnetic wave as a changing magnetic and electric field mutually perpendicular to each other and the direction of propagation of the wave. And then number 2, according to the examination guideline, you need to be able to discuss the properties of electromagnetic waves. Then you need to be able to use the equation C is equals to F multiplied by lambda, or the wavelength, that is to solve problems involving speed, frequency, and the wavelength of light there. Then again, in terms of the examination guideline, you need to be able to discuss the electromagnetic spectrum, that is in terms of the frequency and the wavelength. Then you need to be able to arrange the spectrum in order of increasing or decreasing frequency and wavelength. And then it says you need to state the uses of electromagnetic radiation, describe a photon of light as a quantum of energy. So that is one of our definitions then. Then the last one there, it says you need to be able to use the equation E is equals to HF. That is to do calculations involving energy, frequency, and the wavelength of light there. Then again, according to the examination guideline, so we said, okay, so the first thing that we are going to talk about there is a wave, and then we need to know that definition. So remember with definition, it's either you are going to be given 2 marks or 0. So we don't have half marks in terms of the definitions. So the definition of a wave there, it says it is a succession or it is a repetition of what? Of pulses. So when we speak of pulses, then we are speaking about what? We are speaking about a disturbance. And then according to the examination guideline there, we need to be able to define what? The electromagnetic wave. So electromagnetic wave, it says, is defined as a changing magnetic. So in this case, the blue arrow there, it indicates the magnetic. So it says a changing magnetic and what? And electric what? Electric field that are mutually perpendicular to each other. So what are we saying? We are saying that the magnetic field and the electric field are perpendicular to each other, and they are also perpendicular to what? To the direction of propagation of the what? Of the wave. So again, we are saying the electric field, so this one over here, is perpendicular to the magnetic field. And now the electric field and the magnetic field are perpendicular to each other. And what are they perpendicular to? They are perpendicular to the direction of propagation. So when we speak of the word propagation, it means to the direction of what? Of movement of the what? Of the wave. So that is our definition for the electromagnetic wave. Then the examination guidelines, again, it said we need to be able to discuss the properties of what? Of the electromagnetic waves. So number one, there it says electromagnetic waves, they propagate at the what? At the speed of light. So what is that speed of light? The speed of light, it's the value small letter c. And where do you find that small letter c? You will find that small letter c on your data sheet because it is one of the constants. So small letter c, which has a value of what? 3 times 10 to the power of 8 meters per second. So with this one, again, as I've said, you will find this on the data sheet. So you don't have to know the number off by head, but you need to be able to identify the number on your data sheet. Then number 2, it says, do not need a medium to propagate, okay? So an example of a medium can be a solid, can be a liquid, and it can also be a what? A gas. So it does not need a medium to propagate. Again, the word propagate means what? It does not need a medium to move, and it can be able to propagate through what? Through a vacuum, okay? Then the third one, it says they can be polarized, okay? So this is the third property now. And they can be polarized, and then it says this means that electromagnetic waves are transverse waves. So when we say polarized, all that we are saying is that they are what? They are transverse waves. Then the next one says it has a dual nature. This means that they behave like waves and particles. So dual nature, it means that it can behave like a wave, and then it also means that they can also behave like what? Like particles, and then that is depending on the circumstances. And then the last one, the last property there, it says electromagnetic waves, they transfer energy. Then we need to be able to use the equation C is equals to F multiplied by lambda. Okay, so that is all according to the examination guidelines. So we need to be able to use this formula C is equals to F multiplied by lambda. That is to solve problems involving speed, frequency, and the wavelength of light there. So from the formula, we have C, which is the speed of light in a medium. So again, we said a medium can be a solid, can be a liquid, or it can also be what? It can also be a gas. Then the speed of light, what are the units of the speed of light? We said the units will be meters per second. And then we said what is the value? It's 3 times 10 to the power of 8 with the units meters per second. And we also said that you can get the value on your data sheet. Then we have the letter small f there, which is the frequency of light. And what is the unit of the frequency of light? We measure it in what? In hertz. The next one that we have there is the wavelength. The wavelength or lambda. So this is lambda, or it's the wavelength of light. And the unit of measurement there is what is meters. And that is a small letter n. Then again, we need to know this very important relationship. So this relationship is between the frequency from the formula there and the what? And the wavelength. And it says that the frequency is inversely proportional to the wavelength. So this is the frequency there, and this frequency is inversely proportional to the wavelength. So what does that statement mean? It means that as the frequency increases, okay, so as the frequency increases, it means that the wavelength will do what? The wavelength will decrease. Or it can mean that as the wavelength increases, then the frequency will do what? The frequency will decrease. So this statement is very, very, very important when it comes to this topic. Then we have the next formula there. It says V is equals to F multiplied by lambda. So V in this case is the wave speed or the velocity. So the wave speed or the velocity is given in what? In meters per second there. And then already we are familiar with F, which is the frequency in hertz. And then this one is lambda, which is the wavelength in what? In meters there. So just to show you from the formula sheet, these are the formulas that you are going to get under waves, sound, and what? Under waves, sound, and light there. So how many formulas do you have? You will have about four formulas according to your formula sheet. So whenever you are doing this chapter, you need to use your formula sheet, because the formula sheet will be given during all your examinations there. Then just to show you again on your data sheet, so you are going to be getting the speed of light in a vacuum, which is a small letter c. And then again, you are also given the what? You are also given the value, which is 3,0 times 10 to the power of 8 meters per second. And then again, we are also going to use this one, which is Planck's constant, small letter h there, and with a value of 6,63 times 10 to the power of negative 34 joules seconds. So the units of the two constants will be given, as well as the values of the two constants will be given, as well as what? As well as the units of the two constants will be given there as well. Okay. Then we have the electromagnetic spectrum. So the examination guideline says that you need to discuss the electromagnetic spectrum. That is in terms of what? In terms of the frequency. And again, that is in terms of the wavelength. So it takes us back to the knowledge of what is the relationship between the frequency and the wavelength. And remember, we said that the relationship between the frequency and the wavelength is that they are inversely proportional. So when we say they are inversely proportional, what does it mean? It means that as the frequency increases, then the wavelength will decrease, or vice versa. As the frequency increases, as the frequency decreases, the wavelength will do what? The wavelength will increase. So we need to be able to use the electromagnetic spectrum and be able to identify now where do we have the highest frequency in terms of the electromagnetic spectrum, and maybe where again do we have the highest wavelength or the lowest wavelength. Okay. So when you look at the electromagnetic spectrum there, so we have your radio waves, we have your infrared rays, we have your visible spectrum, ultraviolet, X-rays, and your gamma rays there. So this is what you need to know in terms of the waves there, so if you look at the waves there, the waves on the right-hand side are compressed, okay? So when you see a compression, then you are going to relate the compression with what? With a high frequency, okay? So immediately you see that you have a high frequency. We said, what is the relationship between the frequency and the wavelength? They are inversely proportional. So it means that if you have a high frequency, then you'll be having what? You'll be having a lower wavelength there, okay? So again, if on the right-hand side, you have a higher frequency, it means that where the waves now are further apart, that is for your radio waves there, then it means that you have what? You have a lower frequency. Then you go back to the relationship again between the frequency and the what? And the wavelength. We said that the relationship is that they are inversely proportional. So if you have a lower frequency this side, it means that therefore you will have what? You will have a higher wavelength, okay? Then it says you need to arrange the spectrum in order of increasing or decreasing a frequency and the what? And the wavelength, okay? So we said that in terms of between the radio waves and the gamma rays, because the radio wave is the first one and then the gamma ray is the last one, we said that where we have the highest frequency, we'll have the highest frequency where we have a compression in terms of the waves, or where the waves are closer together, right? So it therefore means that the frequency will be increasing from the left-hand side to the what? To the right-hand side, and it therefore means that there will be a decrease in the frequency from the right-hand side to the what? To the left-hand side. And then that is where again you will put in the relationship between the frequency and the what? And the wavelength. So if the frequency is increasing, going to the right, it means that the wavelength will be doing what? The wavelength will be decreasing, going to the right-hand side there. Then we have electromagnetic spectrum uses, okay? So the first one there is radio waves. By the way, we have a lot of uses in terms of the electromagnetic spectrum. So it says radio waves, it is used to broadcast radio and television. And then we have microwaves. It says it is used in cooking, radar, telephone, and other signals. And then we have your infrared, which says it is used to transmit heat from the sun, fibers, and radiators. And then we have your visible light, which says it makes things able to be seen. Then it's ultraviolet, absorbed by the skin, used in fluorescent tubes. Then we have X-rays. It says it is used to view inside of the bodies and objects. And then it's gamma rays, used in medicine for killing cancer. So again, according to the examination guidelines, you are expected to know all the uses for radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Because definitely in terms of the examination, you will be asked to at least give maybe 2 or 3 uses of any of the following here. Okay, then a photon. So again, according to the examination guideline, it says you need to describe what? Describe a photon. So it says that a photon of light, so the definition is photon of light as the quantum of what? As the quantum of energy there. Then you need to be able to use the equation E is equals to E is equals to HF. Then it says do calculations involving energy, frequency, and the wavelength of light there. So in terms of the equation, we have E, which is the energy of a photon in joules. Then we have what? We have H, which is Planck's constant, and it has a value of 6,63 times 10 to the power of negative 34 joules seconds. So again, remember this one, we said it is a constant, and where are you going to get that constant? You will get the constant on your data sheet, okay? Then we have a small letter f, which is your frequency of the photon, and again, the units of frequency, they do not change because we are maybe now using a different formula. So the units of frequency, they will remain the same, being what? Being hertz there. So using this formula, you need to use, to be able to use this formula so that you can calculate what? So that you can calculate the energy. And you also need to use this formula so that you can calculate the frequency as well. But then again, we also have another one whereby E, in this case, it represents the energy of the photon measured in joules. And then your H will represent Planck's constant. And then your C will represent the speed of light. So with this one, you are going to get the constants on your data sheet. So the first one, H, we said it's Planck's constant. And then C, we are saying it's the speed of light. And then this one, lambda, which is the wavelength in what? In meters, okay? So when it comes to calculating the energy, then you have an option of using two formulas. It's either you can use this one or you can use formula number 2 then. So now again, in terms of the electromagnetic spectrum, you can then use this as a way to remember. So if you can think of maybe someone that you know whose name starts with an R, and someone that you know whose name starts with what? With an M there. So just to remember all of them, we have radio waves, we have microwaves, infrared, visible spectrum, ultraviolet, X-rays, and gamma rays. So how can we remember this for the examination? Okay, so we can use the word, like I said, you can use any name or any surname that you know. So in this case, I'm going to be using Refile Mukwena, went for an intense visit in Uganda to do what? To do X-rays and gamma rays. So that is how we are going to remember. So when you think of Refile, then you will relate Refile to what? To your radio waves, because your radio wave starts with an R. And then when you think of any surname that you are going to use that starts with an M, in this case I use Mukwena, then you are going to relate it to what? To microwave. So we are saying now, just so that it makes sense as a sentence, went for an intense, so we are going to use the letter I for what? For infrared there. And then we are going to use the word visit for what? For visible spectrum there. And then we're going to use the word U there for ultraviolet. And then this one is easy there. So Refile Mukena went for an intense visit in Uganda to do what? To do X-rays. So we have X-rays and X-rays there. To do X-rays and what? X-rays and gamma rays there. So all in all, what do we have there? We have your R, your M, your I, your V, U, X, and what? And G. Okay? So, but maybe it may be difficult just to remember the letters. So maybe it's easier if you say it in a what? In a sentence there. Okay? Then, as we go down from your radio waves to your gamma rays, on your gamma rays there, or whatever that is there at the bottom, will represent what? It will represent a higher frequency. So remember we said in terms of a higher frequency, we said that is where the wave will be what? That is where the wave will be much more compressed, okay? So we have a higher frequency in terms of the gamma rays. And then whenever we have a higher frequency, it means that we will also have what? A higher energy. Okay, why are we saying that? It's because the energy is directly proportional to the what? To the frequency. Okay, so energy is directly proportional to the frequency, even if you are to compare it using this formula there. So if the energy is directly proportional to the frequency, it means that as the energy increases, the frequency will increase, or as the frequency increases, the energy will do what? The energy will increase then. So if you just remember that at the bottom for the gamma rays, we have a higher energy, then you should be able to remember that if you have a higher energy, it also means that if you have a higher frequency, it also means that you'll have what? You'll have a higher energy then. Then you need to remember the relationship between what? You need to remember the relationship between the frequency and the what? The frequency and the wavelength, okay? So at the bottom with the gamma rays, we are saying that if you have a higher frequency at the bottom, it therefore means that in terms of the wavelength, you can use the word shorter or a lower wavelength, okay? So it means that at the top here then, what do we have? So if you have a higher frequency at the bottom by the gamma rays, it therefore means that at the top, you will then have a lower frequency. And then if you have a lower frequency, what did we say about the relationship between frequency and energy? The relationship between frequency and energy is that they are directly proportional, okay? So we said that if the energy increases, it means that the frequency will also increase. So in this case, if the frequency decreases, it therefore means that the energy will also do what? The energy will also decrease. So that is why at the top now we have a lower energy, a lower frequency, and we also have what? We also have a lower energy. Then we go back to the relationship between what? Between the frequency and the wavelength. We said the relationship between frequency and wavelength is that they are inversely proportional, okay? So in this case, it means that as the frequency does what? As the frequency decreases, because we said at the top, we have a lower frequency. What will happen to the wavelength? The wavelength will increase then. So we can speak of the wavelength at the top being longer, or the wavelength at the top being what? Being higher, okay? So for the examination again, that is what you need to know in terms of the electromagnetic spectrum. So at the top, again, if you just remember that if you have a lower frequency, it means that at the bottom, definitely you'll have what? You'll have a higher frequency. And then from there, with frequency and wavelength, you use the relationship so that you can be able to get what? The energy, as well as what? As well as the wavelength there. Now, learners, we are going to do this activity. But before we do this activity, learners, I'm going to ask that we take a 2 minutes break there. Welcome back, Lena. So if you have any questions again, you can send your questions to the following WhatsApp number, 079-578-2908. Again, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. So let us continue here. Then it says the diagram below represent the electromagnetic spectrum. Okay. And the first question there says, define the term what? Define the term photon. Okay. So we need to define that according to the examination guidelines, because remember we said for the definitions, you are not going to get what? Half a mark. You are going to get what? 2 marks or 0. So the definition there says a photon is a quantum of what? It's a quantum of energy. 8.2 says identify the rays what? Identify the rays A and B there. Okay. So remember we said we are going to use this now whenever we are given the electromagnetic spectrum. Okay, so the first one there is radio waves. Then it's your microwaves. So it therefore means that we have now covered radio and microwave. Therefore, it means that your B will be your what? So it's your Refile Mukwena went for an intense visit, right? So intense visit in what? In Uganda. That is to do X-rays and what? And gamma rays there. Okay? So that is how you are going to solve it there. Okay? So it's radio waves, microwaves, and the B in this case, it represents the what? The infrared light. Okay? So after infrared, what is it that we have? We have the visible light, then we have the UV light. So after the UV light, what is it that we have? We have the X-ray there by letter A. So that is how you are going to solve this one. Using radio waves, microwaves, infrared for I, visible light, UV light, X-rays, and your gamma rays there. Okay. Then 8.3 says calculate the energy of a radio wave with a frequency of what? Of 300 times 10 to the power of 9 hertz. Okay. So remember, when it comes to the calculations, you need to use your formula sheet and your data sheet there, so that if ever there is any constants, you are able to get the constants. So let us now check the information that we are given. It says 300 times 10 to the power of 9 hertz. So in this case, when we see hertz, we immediately know that we are given the frequency. And then according to your formula sheet, remember, if you are to calculate the energy, you are given 2 formulas, which is E is equals to HF, and the other formula is E is equals to HC divided by what? Divided by lambda. So in this case, if you are given the frequency between formula 1 and formula number 2, which formula can you be able to use there? The question it says you must calculate the energy, which is E, and then you know that H is your what? H is your Planck's constant, and you are also given the what? You are also given the frequency. When it comes to formula number 2, yes, H is your Planck's constant, C is your constant as well, the speed of light, but then it has what? It has lambda, which is the wavelength, and in this case, we are not given the wavelength. So it is therefore easier for us to use a formula number 1 there. So with formula number 1, you have E is equals to HF. So again, we said H, you are going to get that on your data sheet. as a constant, as Planck's constant. So it's 6,63 times 10 to the power of negative what? Negative 34. And then we are also given the what? We are also given the frequency that is according to the question of 300 times 10 to the power of 9. And then from there, you are able to calculate Planck's constant as well as your frequency. And that is for you to be able to get what? To get your answer. And then we must not forget to put what? To put the units, okay? So because now this is a calculation, so you'll get 1 mark for the formula, 1 mark for the substitution, and another mark for the correct answer with the correct SI unit, okay? Then moving on to the next one, it says, the table above represents the electromagnetic what? The electromagnetic spectrum again. And then 7.2.1, we need to define a wave, and that is for 2 marks. Remember now, this is a definition. So it says a wave is a succession or a repetition of what? Or a repetition of pulses there. Then 7.2.2, it says name 2 characteristics of electromagnetic waves. So remember we spoke about the characteristics of the electromagnetic waves. We had about 5 characteristics of the electromagnetic waves. So in this case, you only need to give how many? You only need to be able to give 2 characteristics there. So one of them there was that it can propagate. So propagate, we said it means that it can be able to move in a vacuum, transfer energy. It can be polarized. We said polarized, it means that it can also be able to act as a transverse wave. And then it has a dual nature. So which means that it can be able to behave as a wave or as a particle. And then the other one, we said it is able to move at the speed of light. So remember the speed of light, it is a constant there on your data sheet. And that constant is 3 times 10 to the power of 8, or 3,0 times 10 to the power of 8. And that is in what? In meters per second. So that is the units. And as we have said, you don't need to know that off by heart, but you need to use your data sheet there. Then 7.2.3, it says arrange the waves in the diagram above from the lowest to the what? From the lowest to the highest frequency, okay? So again, it means you are going to use this again to say, Refilwe Mukwena went for an intense visit in Uganda, that is to do what? X-rays and gamma rays there. So again, we said in terms of the gamma rays, that is where you will have what in terms of the waves? That is where you will have compression. And then in terms of the radio waves, so the waves this side are far apart. And then in terms of the gamma rays, we said that is where you are going to have what? That is where you are going to have the highest what? The highest frequency. So if you have the highest frequency, we then go back to the relationship between what? Between frequency and the wavelength. So we said the relationship between frequency and the wavelength is that they are what? The frequency is inversely proportional to the wavelength there, okay? So it means that if on the right-hand side you have the highest frequency, it also means that on the right-hand side you are going to have the lowest what? The lowest wavelength. So if on the right you have the highest frequency, on the left you are going to have the lowest frequency, and therefore the highest what? The highest wavelength. So 7.2.3, it says arrange the waves in the diagram above from what? From the lowest to the highest frequency, okay? So it means that you are starting from the one that has the lowest frequency, and then you are going to go to the one that has the highest frequency there, okay? So which one has the lowest frequency? It is going to be your R, which is your radio wave, followed by your microwave for M there, followed by infrared for I, followed by visible for V, followed by ultraviolet for U, and then X-rays for X, and then the last one will therefore be your what? It will therefore be your gamma rays. Okay, again, why are we arranging it in this way? The question said we need to arrange it from the one that has the lowest to the one that has what? The highest frequency. So again, after we have done the relationship between frequency and wavelength, we then said that the one that has the lowest frequency is your radio waves, and therefore it means that the one that has the highest frequency will therefore be your what? Will therefore be your gamma rays there. Okay. Then the next one, it says study the diagram below which represents the electromagnetic spectrum and answer the questions that follow there. Okay. So the first one there, it says you need to define the term electromagnetic wave. Okay, so this one is a definition, and it says electromagnetic wave is a changing magnetic and electric field mutually perpendicular to each other and the direction of propagation of the wave. Okay, remember we spoke about this one. We said the magnetic field and the electric field are perpendicular to each other. And then we said the magnetic field and the electric field, they're all perpendicular to what? To the direction of propagation of the wave. So again, we said propagation, we said it means to the movement of the wave there. 7.2, give the names of the two waves which have the smallest wavelength. Okay. So give the names, or they want the names of what? Of two waves which will have, so this is our keywords there. So which have what? Which have the smallest wavelength. So again, we are going to use this to say, okay, Refilwe Mukwena went for an intense visit in Uganda. That is to do what? X-rays and gamma rays there. So gamma rays, so we start there. Gamma rays, they have what? Gamma rays, they have a higher frequency, okay? So if gamma rays have a higher frequency, then we go back to the relationship between the frequency and the what? The frequency and the wavelength. Again, what is the relationship between the frequency and the wavelength? They are inversely proportional, okay? So it means that if we have a higher frequency this side, we therefore have a lower or a shorter wavelength on the right-hand side. Then again, it means that if we have a higher frequency on the gamma rays, then on the left-hand side, we will have a lower frequency. Then we go back again to the relationship between frequency and the wavelength. If we have a lower frequency, we will therefore have what? We will there have a longer or a higher wavelength on the right-hand side, okay? So now going back to the question, give the names of the two waves which have what? Which have the smallest wavelength there, okay? So it means again you are going to look at what? You are going to look at the graph, and the graph will give you a clue as to which one there has a higher frequency. So remember we said where we have compression, that is where we will have what? That is where we will have a higher frequency. So if we have a higher frequency, we therefore said that it means that that is where we are going to be having what? A lower wavelength or a shorter wavelength. So if they say we must give the names of the waves which have the smallest wavelength, it therefore means that the ones that have the smallest wavelength will therefore be your X-ray and your gamma rays. Why the X-ray and gamma rays? It's because X-rays and gamma rays, they have the highest frequency as compared to the others there on the left-hand side. Then the next one was saying name the wave that is represented by what? That is represented by letter C, okay? So now that we have said that on this side we have the highest frequency, then immediately we know that it therefore means that this is our gamma rays. So if the gamma rays is on the right-hand side, it therefore means on the left-hand side then we are going to be having what? We are going to be having radio waves, okay? So then we are going to use this again to say the first one will be radio waves. It therefore means that the second one will be microwaves. And then in this case, it means that our letter C will therefore represent what? It is going to represent our infrared wave there. Okay. Then the next one there. So learners, the next one is a calculation. And on this calculation, I'm going to give you about 4 minutes for this one. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908 there. Okay, so let us continue here. This is question 7.4, and it says we need to calculate the frequency of what? The frequency of wave D there. Okay. So in terms of wave D is this one here. What is it that we are given? We can see that in terms of wave D, we are only given the wavelength in what? The wavelength in meters there, okay? So it therefore means that we can then be able to use this formula over here. So remember, with this chapter, we have this formula, E is equals to HF is equals to HC divided by lambda, okay? So if we are to choose, let's say option 1 there and option 2, the question says we need to calculate the frequency of wave D. So if we are, for example, to choose formula number 1 there, on formula number 1, we do not have the energy. Yes, we have Planck's constant because we can get that on the formula sheet, but we also do not have what? We also do not have the frequency. So we therefore cannot be able to use formula number 1 there. Now, if we look at formula number 2, we do not have the energy. Yes, we have Planck's constant from the data sheet. We have c, which is the speed of light from the data sheet. But in this case, let's see, so we do not have the energy. We only have what? We only have the wavelength. So if we are going to use a formula number 2, it therefore means that we are going to be calculating the energy. And then after calculating the energy, you can then substitute the energy on equation number 1, and then you can be able to calculate what? The frequency there. Okay, but we also need to take note of the Mach allocation. So it therefore means in this case, we can just go straight to this formula over here because it's just a total of what? A total of 3 marks. So if we're going to use this one and then come to this one, then it means that the Mach allocation should be at least 5 marks there or 6 marks. So, but because the Mach allocation is 3 marks, we are therefore going to be using this one here. So according to your data sheet, what is it that you have? You have c, which is the speed of light, and it's a value of what? 3 times 10 to the power of 8. And then the question said that you need to calculate what? You need to calculate the frequency. And then if we look at the information that we have, we are saying that we have what? We have the wavelength in meters. So it means that again, in this case, we are not going to be converting anything because the wavelength is given as what? It's given in meters there, okay? So when we substitute there, we have the speed of light, which we get from the data sheet, as 3 times 10 to the power of 8. So remember, we are looking for what? We are looking for the frequency. And then what is it that we are going to substitute there? We are going to substitute there the wavelength which is given. So the wavelength is given there as 0.5 times 10 to the power of negative 6, okay? So for you to get the answer there, it therefore means that you need to get rid of the 0.5 times 10 to the power of negative 6. And how will you get rid of it? It therefore means that you need to divide on both sides by the same number. So you'll have 3 times 10 to the power of 8, and that f 0.5 times 10 to the power of negative 6. So it therefore means that you need to divide both sides by the same number there. So 3,05 times 10 to the power of what? Times 10 to the power of -6 on both sides, so that it can cancel out on the right-hand side. So therefore, you'll have F being equals to 3 times 10 to the power of 8 divided by 0,5 times 10 to the power of -6. From there, you will be able to get your what? You will be able to get your frequency as 6 times 10 to the power of 14. And then you must remember with this one that you need to write your units. So again, according to the mark allocation, it therefore means that you will get what? You will get 1 mark for the formula, 1 mark for the substitution, and the last mark you will get for the correct answer with the correct SI unit. The next one, 7.4.2, it says you need to calculate the energy of 1 photon of electromagnetic wave D, okay? So it means that in this case, we are going to be calculating the energy, but for which one? The energy for the very same D. So by 7.4.1, what did we calculate? We had to calculate the frequency using what? Using wave D. But now for 7.4.2, it also says that we need to calculate the energy of a photon using what? Using the very same D. Okay. So again, remember we said in terms of the energy, we only have 2 formulas, which is formula number 1 is equals to HF, and formula number 2, which is equals to HC divided by lambda there. Then, so according to our formula is equals to HF, what is it that we have there? So we are looking for the energy, and then what is it that we have? We have Planck's constant, because we said that Planck's constant, you will get it on your data sheet. And then, do we have the frequency? Yes, we have the frequency, because we calculated the frequency by 7.4.1, and that was for the very same what? That was for the very same wave D. So then, Planck's constant, it's 6,63 times 10 to the power of -34. And then what are we going to substitute there? We are going to substitute our frequency, which is 6 times 10, or 6 times 10 there, to the power of what? To the power of 14. And then from there, we are able to get our answer as 3,98 times 10 to the power of 19. And then we need to remember to write what? To write the units. So again, for this one as a calculation, we are going to get 1 mark for the formula, 1 mark for the substitution, and therefore the final mark you will get for the correct answer again with the correct SI unit, okay? So this one, it was just a total of what? A total of 3 marks there. Then the next one, it says the following diagram shows the wavelengths and what? And the frequencies of different types of electromagnetic what? Of electromagnetic radiation. Then it says consider the diagram and answer the questions that do what? And answer the questions that follow, okay? So as the first one there, it says you need to define the term what? Electromagnetic wave, okay? So we already spoke about this one. We said electromagnetic wave is a changing magnetic and electric field mutually perpendicular to each other and the direction of propagation of the what? Of the wave, okay? So again, just to remind you, with definitions, you don't get half marks. It's either you are going to get 2 marks or nothing there. Then we have 7.3.2 there, okay? So 7.3.2, it says, what is the relationship now between what? Between the frequency and the what? And the wavelength of the wave. So remember we spoke about that one. So they're asking about the relationship between the frequency and the relationship between what? I mean, between the frequency and the wavelength there. Okay. So it says the frequency, so this one is inversely proportional to the wavelength. Okay. So we said this statement means that as the frequency increases, the wavelength will decrease. Or it can also mean that as the wavelength does what? As the wavelength increases, therefore the frequency will do what? The frequency will decrease, okay? And so for this one, you will get 1 mark there. So it's either you are going to give the first answer there, or you will give the second one there, because it's a total of what? It's a total of 1 mark. Then 7.4 says a photon of light has a wavelength of what? Has a wavelength of 700 nanometers there, okay? So whenever we see this, it therefore means that we need to do what? We need to do a conversion there, okay? So if it's nanometers, it therefore means that we need to multiply whatever that we have there. We are going to multiply it with what? With 10 to the power of what? 10 to the power of -9. So if we had a micrometer, which is this one here, it therefore means that we needed to multiply whatever that we have there as a wavelength with 10 to the power of what? 10 to the power of -6, okay? So now we have nanometer, so we are going to multiply the wavelength with 10 to the power of -9. So it says a photon of light has a wavelength of 700 nanometers. 7.4.1, calculate the frequency of the photon, okay? So which formula are we going to use there? So it will depend on the information that we have there. So for us to calculate the frequency, let us see if this formula will work. We have C, which we get from the data sheet as the speed of light. And then we also have what we are also given there. We are also given the wavelength. But remember, with the wavelength, we need to convert it. And what is it that we need to calculate? We need to calculate the frequency, okay? So again, it's similar to the previous question. We said that if you would like to use this formula here, it therefore means that, yes, you will have Planck's constant, you will have the speed of light, you will have the wavelength, but it therefore means that you firstly need to calculate the energy. After calculating the energy, that is when you will be able to use what? That is when you will be able to use this formula by substituting what? By substituting the energy Planck's constant, and then that is when you will be able to calculate the what? The frequency. So again, because the mark allocation there is only 3 marks, we are therefore going to be using this formula over here. Okay, so from the formula, you are therefore going to do what? You are therefore going to substitute. So we said C is the speed of light, which is 3 times 10 to the power of 8. And we said that you are going to get that on your data sheet. Then we have F, which is part of the formula there. And then we have lambda. Lambda is the wavelength, which has a value of what? 700 times 10 to the power of 9. We said we are going to multiply with this so that we can convert from nanometer to what? To meters there. Okay. Then from there, again, it therefore means that for you to get your final answer, what is it that you are going to do? You are going to divide both sides by 700 times 10 to the power of -9 so that they can cancel each other out. And therefore, it means that on the left-hand side, you will be having 3 times 10 to the power of 8 divided by what? 700 times 10 to the power of -9. And therefore, that will give you your frequency of 4,29 times 10 to the power of 14 what? 14 hertz. Okay. So because it's a total of 3 marks again, it means that you will therefore get 1 mark for the formula there, 1 mark for substitution again, and the last mark you'll be given for the correct answer with the correct what? With the correct SI unit. Then we have 7.4.2. It says calculate the energy of the photon in question what? In question 7.4.1. Okay. So now we are calculating the energy. So for us to calculate the energy, we can therefore be able to use this formula. Okay, so we are required to use what? We are required to calculate the energy. And then from the data sheet, what is it that we are going to get? We are going to get Planck's constant. And then by 7.4.1, what is it that we calculated? We calculated the frequency there. Okay. So our Planck's constant is 6,63 times 10 to the power of negative 34. And then what is it that we have for the frequency? We have 4,29 times 10 to the power of 14. So therefore, you are going to multiply Planck's constant with the frequency, and that is for you to be able to get what? That is for you to be able to get the energy, for you to be able to get the energy, and then you need to remember to write the SI unit of energy, which is what? Which is joules there. So again, because it's a total of 3 marks, what is it that we are going to do there? We are going to have 1 mark for the formula, 1 mark for the substitution, and the last mark will be given for the correct answer with the correct what? With the correct SI unit. Okay. Now the next one, it says give one function of the following. Okay. So remember, according to the examination guideline, you need to know the functions of all of them. So your radio waves, your microwaves, so all of them up until what? Up until the gamma rays. So one function of an infrared ray. So one of the function there is to transit heat from heaters. It can be used as a night vision equipment, medical treatment of injuries, and it can also be used for security systems. Okay. So because it's 1 mark, it therefore means that you can be able to give any one of the answers there. Then 7.5.2, give one function of the gamma ray. So again, it says here it can be used for sterilizing of food, medical equipment, and for killing of what? For killing of cancer cells. So again, because it is 1 mark, you are therefore required to give, so any one of the following there will be correct. Okay. So with the next one there, learners, I will just give you about 2 minutes to do this one, and then we can be able to do it together then. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079 578 2908. So again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079 578 2908. Okay, so let us continue with this one here. 8.3, it says, study the images below showing the practical what? Showing the practical applications of different types of electromagnetic radiation. Okay, so we are given X-rays, we are given infrared, radio waves, we have gamma rays, ultraviolet rays, and the last one there is our microwaves. Okay. Now it says write down the name of the electromagnetic radiation that, so for 8.3.1, it says that has the longest what? That has the longest wavelength. Okay. So again, it therefore means that we need to go back to this one over here. So we said the R can be your Refilwe Mukwena there, went for an intense visit, okay, in Uganda. So Uganda is the U, that is to do what? That is to do X-rays and what? And gamma rays, okay? Then we need to think about, so between your radio waves and your gamma rays, which one there has the highest frequency, okay? So we said that your gamma rays on the right-hand side, your gamma rays will have the highest frequency, okay? Then we need to think about the relationship between what? The relationship between the frequency and the wavelength. So what is the relationship between the two? The frequency is inversely proportional to the wavelength. So what does it mean? It means that as the frequency increases, what will happen to the wavelength? The wavelength will decrease there. And again, it therefore means that as the wavelength increases, the frequency will do what? The frequency will decrease. So we said that for the gamma rays, we have the highest frequency there. So it therefore means that in terms of the wavelength, we are going to have what? We are going to have a lower, we are going to have a lower wavelength or a shorter wavelength. Then on the left-hand side, if on the right-hand side we have a higher frequency, it therefore means that on the left-hand side, we are going to have a lower frequency. So if we have a lower frequency and we think about the relationship, it therefore means that on the left-hand side, we are going to have a longer or a higher what? Or a higher wavelength, okay? Now, going back to the question says write down the name of the electromagnetic radiation that has what? That has the longest wavelength, okay? So by the word longest wavelength, it can also mean what? That has the highest wavelength, okay? So after the analysis, we are therefore able to see that the electromagnetic radiation that will have the longest wavelength will therefore be what? It will therefore be our radio waves, which is the very first one there, okay? Why? Because we said if the gamma rays have the highest frequency, it therefore means that they must have a shorter or the lowest wavelength. And if that's the case, it therefore means the radio waves on the left-hand side, they will have the lowest frequency and therefore have the highest wavelength there, okay? Then 8.3.2, It says, so write down the name of the electromagnetic wave that is used for security checks at the airports there. Okay, so which one is used for security checks at the airport? That will be our what? That will be our X-rays. So remember, for this one, according to the examination guideline, it said that you need to know the uses for all the electromagnetic radiations there. Okay, so the answer for this one, for security checks at airports, that will therefore be our X-rays there. Okay. Then the next one says, the diagram below shows the electromagnetic spectrum. So we are given unknown letters, the A, B, C, and letter D. In between, we have X-rays, we have infrared, and then we also have we also have radio waves. Okay. 7.1.1 says give the names. Okay, they want the names of the waves represented by letters A, letter B, letter C, and letter D. So it therefore means that we need to give all the 4, because we have a total of we have a total of 4 marks there. Then again, we need to analyze the table to say we are starting with an unknown name there, but on the right-hand side, we are starting with something that we know. So on the right-hand side, what are we starting with? We are starting with the radio waves. So again, it's Refilwe Mukwena went for an intense visit in Uganda. That is to do what? That is to do X-rays and gamma rays there. So if we have radio waves there, the next one is what? It's M. So M will represent what? M will represent your microwave. M will represent your microwave. And then the next one is what? The next one is your infrared. Then after infrared, you have the letter what? You have the letter V, which is what? Visible there. After visible, you have, so it was intense visit where in Uganda. So that is your UV rays. And then you have X, which is your X-rays. So it therefore means that the last one will be your what? The last one will be your gamma rays. Okay. So again, looking at the letters, so we have radio waves. So we are saying after radio waves, it's letter D. Letter D is represented by what? Is represented by M, and M in this case is what? Is microwaves. Then after letter D, we have infrared. So the infrared is given. And then we have letter C. So letter C is represented by what? Is represented by V, which is the visible light. And then moving on, so after letter C, what do we have? We have letter B, and that will represent what? Letter B will therefore represent UV rays, or it will represent what? The ultraviolet rays. Then after ultraviolet rays, what is it that we have? We have your X-rays, which is given in this case. And after the X-rays, we have the letter G, and the letter G is what? Is A there, which represents what? Which represents your gamma rays. Okay, so that is how you are going to get your 4 marks there, because it is the mark allocation are that you are going to get 1 mark for each there. Then 7.1.2, it says which wave series has the shortest wavelength. Okay, so again, if the right-hand side has the highest what frequency, it means that it has the lowest or the shortest wavelength. And then the left-hand side will have a lower what? A lower frequency. If the left-hand side has a lower frequency, it therefore means that it is going to have a longer or a higher what? A higher wavelength. So now going back to the question, it says which wave series has the shortest what? Has the shortest wavelength, okay? So it therefore means that the one with the shortest wavelength will be the one that has the highest frequency. So which one has the highest frequency? That is your gamma rays. Your gamma rays has the highest frequency and therefore has the shortest wavelength or the lowest wavelength there. So this one, it is allocated a total of what? A total of 1 mark just for you to state the word or to write the word gamma rays there. Then the next one, it says 7.2, infrared light has a wavelength of what? Of 50. So we can see that with this one, it's micrometers. So it therefore means that in terms of the wavelength, we need to convert the wavelength by multiplying it with what? With 10 to the power of what? 10 to the power of -6. Now the first question there says define a photon there. So that is our 7.2.1. So again, remember with the definitions, we need to define according to the examination guidelines. Again, that is because with definitions, you are going to be getting what? You are going to be getting 2 marks. So it's either you are going to get 2 marks or 0 for this one. So therefore, our definition for a photon is a quantum of what? A quantum of energy. Then 7.2.2, it says you need to calculate the energy of what? Calculate the energy of the infrared light there. Okay. So we can therefore use this formula because remember, we said for energy, it's either we can use this formula or we can use this formula over here. So with formula number 1, remember the question said that we need to calculate what? We need to calculate the energy. So with formula number 1, we need to calculate the energy. So it therefore means that we do not have the energy. And then with the Planck's constant, remember we will be given Planck's constant and you'll find it where on your data sheet there. And then you also have what? You also have the frequency there. So according to the question, what is it that you are given? You are only given the wavelength. You are not given the frequency. So it therefore means that you are not able to use this formula because the energy in this case is not given, as well as the frequency is not given. So with this, with formula number 1, it therefore means that you have what? You have 2 unknowns, as you will only be having the Planck's constant. Now with formula number 2, the question said that you need to calculate the energy. So the energy is unknown. But from your data sheet, what is it that you are going to get there? You are going to get the value of Planck's constant. You are also going to get the value of the speed of light. And then what is it that you are given according to the question? You are given a wavelength of what? Of 50 micrometers, okay? So it therefore means that the most suitable formula that we can use will be formula number what? Will be formula number 2 there. So from there, we are then going to do what? We are then going to substitute, okay? So Planck's constant will be 6.63 times 10. So this will be to the power of what? Of -4. And speed of light will be 3 times 10 to the power of what? To the power of 8. And we are therefore going to divide this with 50 times 10 to the power of what? To the power of negative 6. And that is for your what? That is for your wavelength, which is given in what? In micrometers. Okay. So from there, you are going to divide your Planck's constant or multiply Planck's constant with the speed of light, and therefore divide everything with 50 times 10 to the power of what? To the power of negative 60. Then you will get your final answer as 3,98 times 10 to the power of what? Of negative 21. And therefore, you also need to remember to write your units. So because we are calculating energy, energy is measured in what? Energy is measured in joules there. So again, this is a calculation which has a total of 3 marks. So that means that you are then going to get 1 mark there for the formula, 1 mark for the substitution, and the last mark you will be given for the correct answer, and that is with the correct what? And that is with the correct SI unit. Okay. So with that, learners, I'm going to leave you with the words of Nelson Mandela, which says that it is in your hands to create a better world for all who live in it. So thank you very much, learners. I will see you next time and at the very same place. Goodbye for now.